All right, so get ready because today we are diving deep into the world of stars. But not just any stars. We're talking about a brand new discovery that has astronomers all hyped up.
Yeah, this is some seriously cool stuff.
You know, I love a good cosmic mystery, so lay it on me.
Well, picture this. We're talking about these binary star systems.
Okay, so two stars like in a cosmic dance. I'm following.
Exactly, but here's the thing. They're kind of breaking all the rules. This is about a recent paper from the University of Toronto.
Oh, I think I saw that one. Dead and Alive. Astronomers uncover star pairs transforming our universe, right?
Yep, published just last week, November 22nd.
So these star pairs, what's so special about them?
The thing is, this discovery could really change how we understand things like, supernovas, even gravitational waves.
No way. Okay, I am officially intrigued, so break it down for me. What exactly did they find?
Well, they found all these binary systems
Okay.
where one star is a white dwarf.
So that's like the leftover core of a star after it.
Right, after it's basically burned out, like what our sun will become eventually.
Gotcha.
And the other star in the pair is a main sequence star. So it's still burning bright, still in its prime. It's like finding a grandpa hanging out with a kindergartner. It just seems kind of odd.
Okay, that is a little strange. But wait a minute, isn't it super common for stars to be in pairs anyway?
Totally. Almost half of all stars, similar to our sun, they've got a partner star. That's not the weird part.
Okay, so what's throwing everyone for a loop then?
It's where they found these pairs. They were inside these young star clusters, like stellar nurseries where stars are just being born.
Oh, so these clusters are like the ultimate symbol of youth and new beginnings in the cosmos. And then you've got a white dwarf hanging out in there like it's no big deal.
Exactly. It's like finding an antique in a brand new house. Doesn't quite make sense, right?
So how do you explain that? How do you get a white dwarf, which is a sign of a star that's already lived a full life, in a place that's all about brand new stars?
Well, that's where the common envelope phase comes in. And let me tell you, this phase is wild.
Yeah, that name sounds pretty intense.
Basically, what happens is one of the stars in the pair, it reaches the end of its life,
Yeah.
and it starts to swell up, becomes a red giant.
Right.
But it gets so big that it basically engulfs its companion star. Talk about a bad breakup.
Wow. Engulfed, like completely swallowed up.
Yep, they end up sharing this, envelope of material around them.
Oh, that's a pretty dramatic way to end a relationship.
Tell me about it. So anyway, think of these dead and alive binaries that they found as kind of like fossils of this crazy common envelope phase. The white dwarf and the main sequence star we see today, they're what came out on the other side of that whole mess.
So by looking at these pairs, it's like we're getting a peek into this really chaotic chapter in the life of a binary star system.
Exactly. And that's the cool part. This stage is usually hidden from view, but now we might finally have a way to understand what really goes on.
So these dead and alive pairs, they're like little windows into a hidden world. And what we see through those windows could change everything.
You got it. And trust me, this is just the beginning. There's so much more to this story, and it has some pretty mind-blowing implications.
I'm on the edge of my seat. You've got to tell me more.
Well, hold on tight because we're about to go even deeper.
Bring it on. I'm ready for the next level of this cosmic mystery.
All right, let's talk about how these star systems are linked to supernovas.
Supernovas, those massive star explosions.
Yeah.
Yeah, let's do it. But first, can you remind me what makes supernovas so special?
Sure. So there are actually a few different types of supernovas, but the ones we're talking about here, the ones linked to these binary systems, they're called type Ia supernovas.
Okay.
Type Ia. And these happen when you've got a white dwarf that's pulling material from its companion star. Kind of like a cosmic vampire, siphoning off energy.
Ooh, that's a pretty vivid image.
And as it sucks up more and more matter, eventually it hits a tipping point, and bam, it explodes in this massive supernova.
So it's like the white dwarf is on this cosmic power trip, and it ends in a spectacular, explosive meltdown.
You got it. And the thing about these type Ia supernovas is they all explode with pretty much the same brightness.
So they're like standardized explosions.
Exactly, like cosmic light bulbs with a known wattage. And that's what makes them so valuable to astronomers.
Oh, I see where you're going with this.
Because if you know how bright something actually is,
Right,
and you measure how bright it appears to us here on Earth, you can calculate how far away it is.
it's like knowing the wattage of a light bulb and judging how far away it is based on how bright it looks.
Exactly. Astronomers use these type Ia supernovas as standard candles to measure distances across the universe.
So these dead and alive binaries, they could hold the key to understanding supernovas.
And not just understanding them, but using them to map the vast distances of the cosmos.
That's incredible. So we've got dead and alive stars, we've got supernovas, and earlier you mentioned gravitational waves.
Right.
I have to admit, that one always kind of blows my mind.
Yeah.
Can we talk about that for a second? Remind me, what are gravitational waves exactly?
Okay, so remember how Einstein said that really massive objects like stars and black holes, they actually warp the fabric of space-time?
Yeah. It's like they create a dent in the cosmic trampoline.
Exactly. And when these objects move around, like when they orbit each other or collide, those warps in space-time, they send out ripples. When you drop a pebble in a pond, and those ripples, those are gravitational waves.
Wow. So it's not just light that travels through space, it's these ripples in space-time too.
You got it. And we can actually detect these waves now, which is amazing because it gives us a whole new way to study the universe.
So how do our dead and alive stars fit into all of this? How are they connected to gravitational waves?
So imagine some of these binary pairs. Over millions and billions of years, as they orbit each other, they lose a little bit of energy, and they start to spiral in closer and closer. Eventually, they might even merge.
Well,
and when that happens, when two really massive objects like white dwarfs collide, they release a huge burst of gravitational waves.
so we're talking about cosmic crashes that send ripples across the universe.
Exactly. And some of the gravitational waves we've already detected are thought to have come from white dwarf mergers. Plus, remember that common envelope phase we talked about?
Yep.
Well, that can actually cause the orbits of binary stars to shrink even faster, which could make these mergers more likely to happen.
So not only are these dead and alive systems helping us understand the common envelope phase and supernovas, but they're also giving us clues about the events that create gravitational waves.
It's all connected. It's like this one discovery has opened up all these different paths for exploration.
So it's more than just finding some weird star pairs. It's about uncovering a whole web of connections across the universe.
Precisely. And the coolest part is that we're really just at the beginning of this journey. There's so much more to discover.
It's pretty amazing how one discovery can lead to so many different avenues of research.
It really is.
But you mentioned that astronomers are still trying to confirm and study these dead and alive binaries. What are the next steps? What's next on their to-do list?
Well, remember how we talked about those massive sky surveys like Gaia and 2MASS and Pan-STARRS 1?
Yeah, the ones that scan huge chunks of the sky.
Right. Those are how they initially found these binary candidates. Those surveys are incredible. They give us data on billions and billions of stars.
It's mind-boggling how much information is out there.
It really is, but the challenge is sifting through it all. Finding the specific systems that we're interested in.
So how do you even begin to do that?
Well, that's where machine learning comes in. They're using these really sophisticated algorithms to analyze all that data and pick out the telltale signs of these dead and alive pairs.
Oh, so it's like having a superpowered detective on the case, searching for clues that would be almost impossible for a human to find.
Exactly. Machine learning is a game changer for astronomy. It's helping us make discoveries that wouldn't have been possible even a few years ago.
So machine learning helps them narrow down the possibilities, but they still need to actually confirm that these systems are the real deal, right?
Exactly. Think of it like getting a hot tip about where to find buried treasure.
Okay.
It might be there, but you still have to go dig it up and see for yourself.
So what are the tools they're using to dig up these cosmic treasures?
They're turning to some of the most powerful telescopes in the world, like Gemini, Keck, and Magellan, to get more detailed observations.
So they're going for that close-up view, trying to see what's really going on in these systems.
Exactly. And they're looking for specific characteristics that will confirm whether these are truly white dwarf main sequence pairs. They want to measure things like the masses of the stars, how far apart they are, how fast they're orbiting each other, all that good stuff.
But they're gathering evidence to build a stronger case, to really nail down the details of these systems.
Exactly. And all of that information helps us refine our models of binary star evolution. It's like adding more pieces to the puzzle, and with each new piece, we get a clearer picture of how these systems work.
It makes you wonder what other unexpected pairings are out there just waiting to be discovered.
It really does. And that's what's so exciting about this field right now. With these new telescopes, with these amazing sky surveys, and with the power of machine learning, it feels like we're just scratching the surface of what's out there.
I'm starting to think that dead and alive doesn't even begin to describe how dynamic and full of surprises the universe really is.
You said it. And that's the beauty of science, isn't it? The more we learn, the more we realize how much more there is to discover.
I think that's a perfect note to wrap up our deep dive. Thanks for taking us on this journey. It's been an incredible ride.
It was my pleasure. Keep looking up. The universe is full of wonders waiting to be uncovered.